Hello everyone, welcome back to my YouTube channel. This is Tech. So today we are diving into the world of data structures again with the sorting algorithms. So some of the most common sorting algorithms are the uh, insertion sorting and bubble sorting and selection sorting. So today we are diving into the uh, most important algorithm called merge sort. So, what is this merge sort? This is a sorting algorithms that follows the dividing and contour paradigm. So, here we are breaking down the array to sort until the single element. Imagine that we have a size 8 array. So, we are going to we are breaking down it to the until the uh, until a, until an element until single element. So here this is actually a very efficient algorithm, and so here there are some of the advantage and disadvantage. The most important advantage here is that we can perform this in the larger data sets than other sorting algorithms. So, such as in larger databases and in the RAM and different large storage places, and also so we can do some of the there are some issues actually. So if we are in the merge sort algorithm, because there are some of the we need some of the extra space to uh, store the breaking down parts. When we are break down 8 array to 4 array and until a single element, so we need extra space. I think you can imagine it. So therefore, it has a higher space complexity. So we need to uh, we need extra storage to save it. Uh, there is a issue on this algorithm. So, however, we will talk about this with the code part and the presentation part. That you will you will get better understanding about this algorithm. Okay, as you can see on the screen, we have a five size array, and we can actually um, find the um, find the mid value of this array, and then we need to separate divide the array into two parts. Firstly, after finding mid value, it will be the index of division. So here we have 52137 as the array elements, and let's find the mid value. So here mid value is LB plus UB divided by 2. Here here LB means the starting element, and UB means the uh, uh, final index, and LB is the lower boundary, the first index of this array. So it is 0, and the last index of this array is 4. So here 0 plus 4 means 2, divided by 2, so it comes 2. So we are dividing this uh, at the second element. So as you can see on the screen, we are dividing it like this. So here it will be breaking down. So next we are getting 5 to 1, the first array that we divided, and we again find the mid value of that. Here it becomes 1 actually. So next we are breaking down, and next we are taking 3 7 as the set that we firstly divided second array. So here when you are finding the mid value of 3 3 7 array, we took this 0.5. So we are getting the floor value of when we get like this decimal values. So floor value is 0. So it becomes as you can see on the screen, 5 2 still has in the red circle, it still has 2 elements, and but others has 1 element in the green circle. So we no need to call these 1 3 7 again. We need to break down 5 2 until a single element. So let's again break down this. When you find the mid value, it comes as 0.5. So again we are breaking down at 0 because the floor value is 0 here. So we are done with first step of this array, first step of this merge sorting. So next we are getting the 5 2 1 3 7 as the single elements. So next we are merging this as these three as the 1 2 5 because it is the ascending order. We are making our single elements as the breaking down. After the breaking down into the single element, we are again merging as in the ascending order. So as you can see on the screen, 1 2 5 become the correct order, and in this 3 and 7 3 7 is the ascending order. So in after this has made, we are comparing 1 2 5 and 3 7. I have defined I as the left array's index and j as the right array's index. So when we are comparing, and after we comparing, we making the final array, which is the sorted array, which is in the ascending order. So as you can see on the screen, 1 is the less value, low value. So therefore it becomes it comes to final array, and then I become plus. I means the left array index. So 2 and 3 will be compared, not changing the j value. J value means index of right array. It not becomes changed. So here we are again taking 2. So what do you think? Well, what value will be changed, I or j? We are taking the 2 from the left array, so it becomes changed. That one's index becomes changed. Index becomes plus, so I becomes plus. So here it goes to 5, and again comparing with 3 because this 3 is not changing, because why? We are not taking any element from this right array. But here when we are but in this step we are getting 3 from this right array. So therefore what will happen? The j will plus. Okay, let's see. The j will plus. So 7 and 5 compared, and this value will be printed in final array. So it is 5. So next we have only remaining the 7. So it will be automatically come because it is not an it is not a it has not to compare with another element. So as you can see on the screen, it becomes, so array has sorted. Let's go to this. Let's go to the code part of this uh, array merge sorting algorithm. So when we are going to the code part of this merge sort algorithms, as you can see on the screen, the merge sort class becomes like that merge, and the merge sort becomes the this is the way we can actually understand. This is the code part you can see, and this will be uh, taken to recursively divide the array until a single element. I think you can understand. Merge sort will be recursively here. Here it will be recursively uh, calling until a single element. I showed you how it happened in the demonstration in my video before. You can watch it, and then this is the main part. This is here we are defining the array and printing the array. So here the merge means the merge method means that we are going to uh, gather the elements. I showed you that we gathered the 137 and 135 again uh, with the conditions, the ascending order of the conditions. I will upload this code part to my description, and let's run this. Uh, is this working? Ensure this is working. So you can see the original array is this, which we taken as our initialization. So sorted array becomes this. So I think you can understand how this becomes. So thank you for listening.